Okay, first off I've got the weight of the particle at P going straight down, and that will be 0.3 g. The only other force I've got going on there is the normal contact force at right angles up there. So those are my two forces. I always want to put on the acceleration, and the acceleration will go into the circle, so it's going round like so. And the acceleration going inwards, double-headed arrow, will be A, and it's going to be either, it's going to be right up here, it's going to be A equals R omega squared or V squared over R. And this first one is about the angular speed, so pretty obviously it's going to be the A equals R omega squared. I want to get some angles in there, so that's 30, so is that here, and line straight up, that's 30, therefore this bit is 60. Okay, so it's a bit small. First off, I'm going to have to resolve upwards. It's going in a horizontal circle, so therefore I can resolve this part's I can resolve upwards, and I'm going to have the upward forces equaling downward force, and so that will give me R, and I want this component of it here, so that will be R cos 60. So R cos 60 will equal the downward force, which is 0.3 g, and so R will equal 0.3 g divided by cos 60, which is 5.88. Next I want to resolve inwards, and here I'm going to have resultant force equals mass times acceleration, and the resultant force going inwards, well, I worked out what R is, so it'll be 5.88, and then it's going to be sine 60. There's nothing else there, and that equals the mass, which is 0.3, and then times by R omega squared, but R we know is 0.12, so it's 0.12, and then times omega squared, and that will tell me that omega squared equals 141.4508, and therefore omega equals 11.89330. Let's keep going, and that'll be radians per second. So that's done the first part, and now the second part. I'll start up here at least. Okay, so it's part 2. I've now got to work out Q, and it looks like it's actually touching twice. So I can draw this a little bit more here, so it goes down here, across like so, and that's going to be 30 degrees here. And we've got the ball on there, as you can nearly see with mine. Obviously it's got the weight coming straight down, so that'll still be 0.3 g. It's got a horizontal normal contact force, we'll call that RH, but it's also touching here, so I have a force going up there at right angles to this one. I'll call it right at an angle, so I'll call it RA. Need to get some other angles within here, so it's 30 degrees, so I'll put this down here. Sometimes finding the angles can be the hardest actually. That's 30, so that's 30, so this bit here is 30, that's a right angle, so we've got 30 here, so this angle here must be 60, so this angle here must be 60 degrees. I think I'll probably be okay now. So I certainly want to put on the acceleration. The acceleration is going inwards, and we're going to have acceleration equals, and this time it wants us to, it tells us a speed, so this is going to be v squared over r. I may have to change the other one, but I'm certainly going to have to do that. I think I pretty much got, I need the velocity on there, so it's going around there at 2.1 meters per second. Well, the first thing, as usual, I will resolve upwards. There's no acceleration because it's a horizontal circle, so therefore upwards must equal downwards. The only upward force I've got is this component of R going straight up there, and I have a horizontal component going inwards, but I don't actually need that one just yet. So this force here I've got is going to be RA cos 60. So I've got RA cos 60, and that's going to equal the 0.3 g. and that will say that RA equals 5.88. So I've worked out that first bit, and now I'm going to resolve inwards. Always worth saying what I'm going to do. There is an acceleration, so it's going around in a circle, the direction is changing. So the resultant force is mass times acceleration. And what have we got going inwards? We've got the whole of RH going inwards. And we've also got this component here of RA, which will be RA, which just worked out is 5.88 sine 60. So it'll be 5.88, it's going to be a 5.88 sine 60. And that will equal the mass, which is 0.3, times by V squared, which is 2.1 squared. And that's over the V squared over R, and the radius of it said was 0.2. And we want to find out what RH is. If you follow that through, RH gives you 1.5227706. So, and that has calculated magnetic force, which is cylindrical shell. Cylindrical shell is this part here. The rest of it is the cone bit. So I've done that bit. And now finally, part 3, calculate the difference between mechanical energy. Mechanical energy, that's potential energy, and kinetic energy at P and Q. So let's work out energy of Q. And this will be potential energy plus kinetic energy, which is mgh, and that'll be a half mv squared. So I've got to work out m, which is 0.3, times g, 9.8, times by the height. Well, the height, I've got to work out that bit there, and I know that the bit goes across there. It says it's 0.2 for this bit here, so I want that's 30. Make a triangle. That's 30 degrees. I want to find the height there, so it looks like it's going to be TOA, and I want the adjacent, so that will be the opposite, which is 0.2 over tan 30. So that's what the height will be, 0.2 over tan 30, and then it's plus a half times the mass, which is 0.3, times v squared, 2.1 squared, and so that equals this energy of Q, 1.679945. That's the first bit. And now I need to work out the energy of P. Again, it's going to be potential energy plus kinetic energy. And this time here, potential energy of this, it's going to be mass, so 0.3, times by g, 9.8, times by this will be 0.12 over tan 30, because the radius, the distance there is 0.12, and it's going to be plus a half, and m is still 0.3, and it's going to be times v squared. I don't know what v is, so I've got to work out v. I know that v equals r omega, and so v equals r, which is 0.12 times omega, which we worked out earlier was 11.89 from down there, so 11.89, obviously keep more accuracy, and so v equals 1.427197, so that'll be here, so 1.427, all that figure there, squared, so that's half mv squared, and that equals 0.91660128, and so the diff is 1.679945 minus 0.91660128, which equals 0.76334458 joules. Obviously I may have rounded a little bit wrong, but that's 6 done.